you. Actually, let me share my screen. Cool. Can you see the screen?
Perfect.
Awesome. Yeah, so we're going to be talking about software quality in microservices, right? We have monolith and have the microservice world. So it's going to be like a not a deep dive, but an overview of what to watch out for in what we are looking at wise in related to microservice. So today's topic is going to be microservice architecture. Is the test pyramid still relevant in microservices? How to guarantee communication in microservices? The test environments in microservices, if you should do testing production, blue, green, canary, and the 4 key metrics to measure if you are doing well or not. All right, so first of all, who am I? My name is Rafael Lima. I've been working in tech since 2003. I started as a dev, then I became a QA, then I became a QA team leader, then I went back to dev, then went back to QA, and then became a dev team leader, and now I'm an SDET, a QA/dev. I'm a bachelor in computer science. I've been working with test automation since 2010. I work at Torex Brazil for 7 years. And during those 7 years, 4 years, I worked in a client in Silicon Valley, and 1 year as a lead of a training program for junior consultants to upspeed them into the craft. And I've been in London at Wise in the last 2 years dealing with microservice, autonomous teams, and not self-employed, that was a bad translation. That's autonomous teams and an average of 100 plus deploys to production per day. So that's the reality we have at Wise right now. I'm going to send this PDF to Ashley so he can share, but these are my contacts, my GitHub, my LinkedIn. I have a YouTube channel called QAOps that I go over what I believe a QA person should know or how they can interact in a DevOps environment as a QA. And I also have a Telegram channel in English as well. Cool, without further ado, so let's go into microservices. So before microservice, we had monolith, right? So, and by monolith, I'm talking about like a framework like Rails, Grails, Django. You have the, I don't think I have a screen. Can you see my screen? My red dot here. The red dot that no, you cannot see my red dot. Yeah, that's actually
it's just
cool.
A cursor.
But yeah, there's the cursor. Okay, cool. So you have the interface with the user. You have a desktop. You have a mobile. You have a TV. This is supposed to be a TV. And then you have a REST API. You have the services, and you have the database, right? So everything is one single application. There is no division between applications. It's one single deploy that has everything there. So that's monolith, right? When you're talking about microservice now, you have the same thing as a monolith. You have the interaction with the users, the REST API and the services. This service can connect to a database, but this service can also call now another service by a REST API, right? This service, the same service that call one of the service can call another service. This one has a REST API and also has a database, right? There we can have another service now that has the database, REST API, but also has a user interaction as well. So we have multiple services with DB, different DB accesses, and different user interfaces, right? But now we are talking about synchronous communication, right? Everything is synchronous. You send a request, you need to wait for a response, and then you go, you do whatever that response did. We can also have a asynchronous communication. That's when you have a queue strategy. Could be RabbitMQ or Kafka. So in this reality, this service here is sending a message to a queue, and whoever wants to listen to whatever the service created is going to listen to that specific queue, is going to connect to that queue, and is going to get that communication. So, and then it can expose in an API or it can do whatever, right? Or all of these services can connect to the same queue and get that all of that information synchronously. So that depends on this strategy. The reality of this is going to, it makes the streamline of events much faster. You don't have to wait. Your ability to deal with the amount of events and requests, it's huge. Of course, it also brings complexity as well. Cool. Right, so the reality that I just showed you is like 6 microservices, which seems pretty straightforward. That was the reality that I had at Thorex in my last client. But now when I join Wise, boom, now I have 405 microservices, which gets a little bit more complicated, right? So when we go into Martin Fowler blog, he talks about microservices, what you need to have in order to succeed in a microservice architecture. So you need to have fast provisioning, right? You need to be able to speed up containers, machines, whatever you need really fast, because otherwise it needs to be automated, it needs to be fast, otherwise it is not feasible for you, right? You also need to have monitoring and observation, right? So you need to be able to monitor and observation. And the difference between monitoring and observation is you monitor what you know, and you observe what you don't know. So when you are monitoring exactly, you are monitoring 404, you are monitoring, let's say, other kinds of failures. You are monitoring usage, you are monitoring everything that you know, but you observe things that looks weird. So let's say you are expecting in one day to deal with, I don't know, let me guess, 1,000 requests. So in a particular day, you already went over those requests, or you are way below. So you are observing that and you feel that something is wrong. That's when you want to interact, right? I also compare monitoring and observability with scenario testing and explore. Right? So when you're doing scenario testing or you're doing automation testing, you know exactly what you want, what you're looking for. When you're exploring, you are looking for the unknowns. You don't actually know. You are exploring to see the unknowns there. You need to have fast installation. So not talking about provision anymore, because the provision is the machine itself. I'm talking about the service. So you need to be able to deploy really fast, right? So this is Martin Fowler idea of how to see the microservice. But now we need to be able to measure as well the performance of those microservices of the company itself. How can you measure if everything is going as expected, if you are attending, and what is attending means, right? So there is a 4 key metrics created by Jez Humble. Jez Humble is the author of A Continuous Delivery, and he created a book called Accelerate. And every year he releases, I don't think he released last year, but every year he released a state of DevOps with the update of those key metrics. It was basically a study to understand how companies measure their service performances. And he, based on the responses he got, I don't know, couple of thousand responses of companies, and he was able to get a model of what are the 4 key metrics. So the first key metric is deployment frequency. How frequently you deploy to production. Right? The second is lead time for change. Right? In this case, he calls delivery lead time. It's not lead time from idea to production. It's from commit to production. And why he removed the idea from production is when you go all the way from the idea, creating the mapping the business, creating the story, before the commit, that's a human process. So he wanted to remove that because that's hard to measure. Each company is going to do their own processes, and it's really hard to know if there are any waste or not. So he removed that and he said, okay, let's get from commit to production, because at the moment that you commit, you have a timestamp of that commit. When you deploy, you have the timestamp of the deploy, and then you can measure that. So and that's going to be the same for any team, right? So that's the lead time for change, how long it takes for you to go from the first commit to production. The third one, sorry, is the change failure rate. So the percentage of installations of deploys that cause a fail in production. So what is that percentage? And finally, how long does it take for you to restore that service? Once that fails, how long does it take for you to recover fully from that, right? So usually it has this table. Every report comes with this table, and it changed a little bit of the year. So the latest one, it came with the elite group, because, and this is not his idea, was the model based on the answer. So the company were responding related to deployment frequencies, lead time for changes, and so on and so forth. So in the first report, it was high, medium, and low. And in the last year of the report, the higher performance created in themselves another group, which became the elite. So the deployment frequency for the elite group is on demand, so you deploy multiple times per day. The lead time for change, it's less than 1 day from commit to production. The time to restore service is less than an hour. And the change failure rate is between 0 and 50% of changes that becomes an issue, right? Otherwise, we are kind of like here, we have multiple deployments, depends on the team, right? We have, as I said, 400 and something microservices, 70 teams. Some teams, they are able to do more deploys than others. But in general, we are there. The lead time for changes, that also depends. We deal a lot with pull requests, since we need to comply with a lot of regulations. And one of the, I'm not sure if I can call it a law, but one of the regulations is you need to have a second pair of eyes approving any code. So when we have auditions, every now and then the regulators come to us and they want to audit if that actually happened, right? So we need to have PRs for everything, and that slows us down a little bit, but we are able to map based on the 4 key metrics, what is the difference between a PR in the same team or a PR in a cross team. So based on that, we saw that a PR in the same team is much faster to be approved than a PR cross team PR. Right, so then we can map now we already did, not fully, but we started, and there's some work. We were able to map and change a little bit of architecture. And by that, I mean, let's say verification. If I want to verify that I'm able to do a transfer, or if my ID, right? When you are doing fintech, you need to verify the user. So the verification in Brazil is different than verification in the UK, and it's different than the verification in the US. So before, we had on one single service that did verification for everything. And the teams that was dealing with different markets would have to change their code, the original code, the core code, to put their changes. So now they changed the architecture, that now you have the core of a verification as a service, and you have a service for LATAM or Northern to deal with different markets. So the LATAM code now verifies the code for LATAM itself, and if you need something from the core verification service, just call the core. But the specificity of the Brazilian market is on the LATAM verification service. The time to store, it's around an hour. Depends on the issue. I guess 2 weeks ago we had an outage in AWS, which was bigger than what we expected. Though some of the stuff happened, but usually it's pretty fast to recover. And the change failure rate also depends on the team, but it's between 0 to 15%. What I found, I did an analysis on rollbacks, and I found that the teams that do most deploys, they have less fail rates. So if there is a team with less deploys, let's say 2 deploys, 3 deploys a month, the percentage of failures in their changes is higher. And the team that has most of the deploys, they have less fail rate, which makes sense, because if you are doing a lot of changes, you have a solid pipeline, you have a mature pipeline, you have a mature process, a mature code, a mature team. So you're going to have less problems with the deploy. But if you have like a legacy code that barely has changes, it might barely have tests, then you're going to have a high change fail rate. Cool. And what about test pyramid? That's something big on my head. Test pyramid in microservice, because I'm not really sure if it's still valid or not, but let me go and do a quick overview of the test pyramid if someone in the call or watching this is not fully aware. So this is the test pyramid. You have unit test in the bottom. This is the ideal test pyramid. You have component test, and by component test, I'm saying the test between multiple units. So you're testing the controller with a model, for instance. Integration test, now in the integration test would be the same as a component, but now you can call the database straight. You don't stub or mock the database. API test is just for test the API. End-to-end, just for the end-to-end flow, you could have like a separated UI layer as well, and then you have manual exploratory testing. As below the pyramid, you are more isolated and you are faster and you are cheaper to create and to execute. And as you go up the pyramid, you are slower, you are more integrated, and you are more expensive to create and to execute those tests, even for a machine. Right? Of course, that if you are more isolated, the test gives the user or the developer less confidence. If you are more integrated, you have more confidence that more code is being exercised. But then that's the question, is the test pyramid still relevant in microservice, right? So I haven't found any article from Martin Fowler or Sam Newman or any of these known folks talking about this, right? So, and that's something that I'm really interested in getting to read more on literature related to it, but I don't really find it. But otherwise, we have been discussing this. So what is the purpose of the test pyramid, right? Of course, this is my opinionated view. So the primary purpose is a fast feedback. You want to have a fast feedback on whatever you are pushing to your CI, right? So you want a fast feedback, and by fast feedback, I'm talking about 10 to 20 minutes. The secondary purpose is you have a lower cost for testing, right? You want to ensure the quality of your release candidate. And that's the purpose of the test pyramid, because if we go back here to the drawing, you have more isolated tests and less confident in the bottom, and you have less integrated and slow at the top. And combining those two, then it gives you the confidence and the fast feedback that you're not breaking anything, right? Cool. But now the question is, do I need to worry about which layer of the test pyramid to write my test in a microservice architecture, right? And to answer that question, or at least to try to answer that question, I took a sample of 6 microservices at WISE, and they have, those 6 microservices, they have an average of 20,000 lines of code, right? And according to our SonarQube, in order to have 100% test coverage for those 20,000 lines of code, it would be required 1,300 tests, roughly a little bit more, like 1,371 tests to cover all of those lines of codes. Now, a service that has 100,000 lines of code would require 16,000 tests, right? So, of course, 100,000 lines of code, now I'm talking about a monolith or a legacy code, right? And also I did a benchmark on API test. So I got a fairly simple API test, and that API test just call simple setup and just call a couple get and posts. It took around 500 milliseconds. So 1,371 API tests, each one with 500 milliseconds, it would take 11 minutes to run. So this is a fast feedback. If your whole suite takes 11 minutes for you to figure out if you broke something, that's fast. So in this sense, I could have all of my tests in the API level if it's possible, and you still have fast feedback. On a legacy code, on a monolith, that would be not possible. That would take ages for you to finish, right? To finish running, yeah, and it would be very complex. So the takeaway that we take from this, that we're taking from this at WISE is, you write the test that you think is necessary, regardless of the shape of the pyramid. You only care about the total time of the suite, and of course you care about having the confidence of that the test pyramid give it to you, not the test pyramid, the confidence that the test gives to you. What does that mean, right? So that means that if I'm writing a unit test and I need to mock something, or if I need to stub something, I don't stub. I don't need to stub. I just write a test that's going to call that service straight. We have Docker containers, right? I can spin up a database really fast using a Docker container. So I don't need to stub my database either. I just use the real database, not the real instance, but a Docker instance of the database. I don't need to stub another service if I want. If I want to check service A communication integration service B, I don't need to stub service B. I can just spin up service B with a Docker container as well. And then I have the confidence that everything is working. So that's what I mean about test whatever you think is going to give you the confidence, and do not attain yourself to the shape of the pyramid. You'll be, I think you'd be easier, and you're going to be faster. You're going to have less, what I'm trying to say, less sensitivity on your tests, because unit tests are very sensitive. You change a lot of stuff, and then you have to refactor all your unit tests. Cool. So now we're talking about 500 microservices. Then how can I guarantee that those services communicate? Because one thing is, I can guarantee that one of the services is working beautifully, but now if the communication with another service is flawed, fails somehow, then doesn't really matter if the service is working beautifully, the communication is flawed. Right? So one of the things that we're also considering was doing, should we do contract testing? Right? So let me explain a little bit about contract testing. So usually in nowadays in microservice, you are communicating between services using JSON files, right? Some services use XML, but I believe XML is not very common. So the JSON one would be this, right? You have an ID, you have a name, you have a category with ID and a name, and you have a array of photos, and you have a state, right? The problem is you need to make sure that the type and the key are the same between those services, right? So by that, I mean, the name, it needs to be name, N-A-M-E. It cannot be nome in Portuguese, changing the A for O. It needs to be the exactly same key. It cannot be capitalized as well. It needs to be the same. If it's everything lowercase, it needs to be everything lowercase. The ID 10 is an int. It needs to be an int, it cannot be in string. Right? Especially in Java, because the code is going to be mapping this way, right? So this is an animal. I'm going to have in my code, when I get this and when I'm deserializing this, I'm going to try to map the ID into a private int ID. The same for the name. The category is going to be mapped into a class category, which has ID and name as well. The photo is going to be a list of strings. So if anything is different than what is expected in the animal class, it's going to give a parsing error, right? And that's when the contract starts to fail, right? So how can you guarantee the contract, right? So contract testing is basically in a book called Microservice by Sam Newman. He talks about how to guarantee communication between microservices, and in his idea, regardless of the shape of the test pyramid, you have contract testing between those services, and then you guarantee the service functionality as a black box and a white box, and then between the services you would do contract testing, and if everything worked, you might not need end-to-end tests, right? So that's his idea, that you should not need end-to-end tests if you did this approach. So what kind of contract testing you do? Basically, you have consumer-based contract testing and you have provider-based contract testing, right? In the provider-based contract testing is the provider that is testing themselves, basically. It's not checking on the consumer itself. I believe the most efficient one would be the consumer-based contract testing, because now as a provider, I want to make sure I'm not breaking my consumer. In this idea, you have me as a provider, I created a repo that each consumer of mine would upload the expected contract to that repo. So if you're using a library called packed.jvm, packed.jvm creates this contract for you, and it's called a packed file. So you would upload the packed file to this repo. The consumer too would do the same thing. And then the provider, as part of the pipeline, would go to this repo and say, hey, now I'm going to download those packed files for those two consumers, and then I'm going to run tests against those packed files to make sure that I'm not breaking my consumer, right? Of course, I need to remember that I might have consumer 100, so I would have to test this against 100 contracts. What is the problem of this approach, right? So the problem of this approach is that if one of the consumer does not upload the contract, then I have a problem, because I do this approach because I want to make sure I don't break in my consumer. But if I cannot guarantee that every consumer is uploading their contract to this repository, I cannot guarantee that I'm not breaking all of my consumers, right? And again, otherwise we have more than 500 services, we have autonomous teams, so there is nobody say, everybody needs to do this right now. So this is not going to happen. So I cannot guarantee that. And if I cannot guarantee, it's a flawed process. So how can I do, what else can I do to make sure that I'm not breaking the contracts, right? What are other forms of communication that we can use? Give me a second just to. Cool. So I took a look at gRPC, which is a Google RPC implementation. And I found really intriguing because it's basically communication between two systems, and those systems can be in different languages. So I can have my server in the example, I can have my server in C++, and I can have a client in Ruby or in Android. So that means that I could have a client in front end or mobile or whatever, and it would work, right? The problem with gRPC is require a lot of maturity to the team, and it works because it communicates using proto requests and proto responses. And who communicates with the server is not the client itself, it's a gRPC stub, and they have the stub. It's called stub, but it's a real implementation. So the gRPC, they have stubs in Ruby, in Java, in iOS, in everything now, right? So that's why it's agnostic. So the problem is that it requires a lot of maturity. One of the teams that that I interviewed that implemented this, he was talking to me related to the specifics, the complexity of the gRPC. So the first complexity is you don't know if the communication finished or not, right? So your code needs to figure out if it was expected, if everything was in the package was sent or not. Your code needs to figure that out, right? You don't have timeouts, right? You don't have HTTP code. You don't know if it was a 404, 500, whatever. So your implementation, it's the both end of the code is the one that needs to know if something went wrong. So it requires a lot of maturity to the team to actually implement these safely. So we also scratch this as a company-wide strategy for communication. So one of the things that we are using right now is we are using libraries, right? So by library, I mean, instead of giving you a HTTP contract with GET and posts and JSON contracts, I would give you a library, dependencies that you download. And you would be able to, instead of doing a GET to an endpoint, you'd be able to download the library and you can do a animal store, get animals available. And the get animals functionality of my library would do the HTTP GET request. So you don't need to worry about the contract itself. Your library would do that for you. Your library would give you the GET request. Your library would also give you the animal class, the animal class type, so you can do the parsing for you, and everything would be done by the library. Of course, you wouldn't need in this scenario. You don't need contract testing. You do need, however, to test the functionality of your library. You need to do functional tests on the library itself. But not everything are flowers, right? We have a couple issues with these two. And one of the biggest issues that we have is when you're talking about enums. So in Java, I have two versions here. So we have the version of the library v2, and I have the version of the library v3. Sorry, I forgot to translate the name of my enum class. This is animal state. So v2 and v3, right? So in v2, you have available in the enum, deleted, and waiting. In v3, you have available, deleted, waiting, and shipped. So if one of my clients, one of my users, let's say, are still on the v2 version, it did not update to the v3, when the server returns a v3 of this enum, it's going to give a parsing error because it does not understand the shipped. So we're going to have an error that's not going to be able to figure that out, right? And depending if that went to the database, if that went to the Kafka, then you can have like it's called a poison pill on Kafka, which is a message that cannot be, that stay on loop, trying to be processed, right? So if you are using Kafka, your code needs to implement a dead letter queue strategy to, if it's not able to read a message like 5 times in a row, it sends to a dead letter queue. RabbitMQ does that built in, but then you need to have some sort of strategy not to have that. So this is one of the things that we are dealing with. So how can I guarantee that all of my clients are using the correct version of the parsing library, right? So we have two strategies. One that we are using is called, we have a service called synchronous service. That is a service that any person can go there and create rules. So to pass the rules, that synchronous service has the ability to go into every code wise, every repository, and it's going to inspect that code based on the rules that you created. And then we can have a rule say, check the version of this library that's being created by the provider and make sure everybody is up to date to that version, right? So that's one of the rules that you can do. But that's not, synchronous service does not reinforce that. Synchronous service let the service owners know there's something wrong and they need to interact with that, they need to fix it, but they are not obligated, sorry. They are not required, easier word. They are not required to do that, right? One of the things that we are studying now is, can I put this on my pipeline, right? On my CI before we generate a Docker container for you. We can check if you are using an out-of-date version of a certain library, and we would block you from going to production, and then we would prevent you and to have some issues, and we would force you to fix the issue. So that's something that we are still studying, how we can actually implement without giving much of a hassle to the teams. Cool. We need to also talk about test environments. Right? What kind of test environment we have at Wise, right? So in my previous, actually, how many test environments do we need, right? In my previous job, we had a dev environment, we have a QA environment, we have a showcase environment for showcasing, we have a pre-prod environment, and we had the prod environment. So each team would have, besides prod, 4 environments. So are all these environments sustainable? So we need to maintain those environments. You need to maintain the data of that environment. You need to maintain the stability of that environment. Right? We had only 6 microservices, so it's fairly easy to maintain those and not that expensive. But how can I do that with 400 plus microservices and 500 engineers, right? Our old solution was called staging. So in staging, we have an example of the problem we had in staging was we have a person trying to test one of a service called service A. Another person would come and say, hey, now I want to test in staging my service B. A third person would come and say, hey, I want to test my service C on staging. So the problem right now would be already that service A might not, the person from service A might not know that the person from service C is testing service C, right? So service A might think that service C would be a reliable service, but that service still being tested. So it creates inconsistency. But of course, it could come another person that wants to also change something on service A, especially now that everybody is remote, and change something in service A, and the first person from service A wouldn't know that. So what happened was staging was always broken. It was always unstable. You could not rely on the data. You could not rely that the result that you were getting would be the same result that you would be from a service in production. So what we did, and this is this responsibility of my team, we created a solution called custom environment, which is basically a environment in a Amazon AWS where any engineer can go to Slack. We have a Slack bot and say, hey, create Rafael. And you would create an environment with as many services as I want. The default number, I think, is 70 services, but you can add more. As long as the service are able to, you are able to run Kubernetes on that service, it's able to spin up using Kubernetes. We can spin up that service. So now you have your own integrated environment with everything that you need. You have a deployment solution there. So if you want to change a different version, you just put the number of your Artifactory Docker image, and it's going to download and deploy that version to you. By default, we give the same versions as in production. By default, you have all of the version that's running in production in the moment. And one of the things that we created is you are able to, as a developer, you are able to authenticate your local machine to this environment. So you can be coding and checking as the moment that you finish your code or you're still coding, you can check instantly in the environment how that look like, because now your computer is a part of this environment itself. So it's communicating with the environment. So you can see the whole process live as you are coding, right? We still use staging today, but more for infrastructure stuff, because custom environment is a very different infrastructure than production. So if any of the platform teams needs to change something in the network or in the cluster itself, custom environment is not going to give them a reliable testing experience. They need to use something closer to production, which is staging in an infrastructure way. Cool. What about testing in production? Should we do testing in production? Yes, definitely. Some of the stuff that we deal with is never going to be able to test in a testing environment. For instance, real money. I'm never going to be able to send money from A to B in a test environment. I want the money from my bank account to go to Ashley bank account in my test. I'm never going to be able to do that on a custom environment. I need to use the real thing. There are some ways that we can mitigate this. So for instance, not sure if whoever is watching this ever use Wise, but you can have balances there. You can have money there. It's not only to transfer money from A to B, but you can store money as well. So in our test environment, when we spin up a custom environment, you have already some testing data with a couple million currencies. Not a couple million currencies. You have 4 currencies: USD, GBP, Australian dollars, and Canadian dollars, I believe, euros, and like 1 million units in each one of those. And then you can use that balance to do some testing, right? You can, if you are testing to pay something, you can use that balance to pay that something, right? But still, it's still simulated, right? We are simulating adding money. We are not actually adding money. So what we do, we have a smoke testing production that tries every minute to send money from one person to another to make sure that we are reliable and that flow is being used. That is smoke test. That's the most basic scenario that we have, and that's why we run every minute. We also do Canary Releases, right? So that's a way we can make sure that our change is not going to break production, and if it breaks, it's going to affect a less amount of users. So for those not familiar with Canary Releases, so this is the idea of Canary Release. You have the user, and then you can redirect the user to the old version. Like, so in this case, we are redirecting the 100% of the user to our older version. Now I can say, okay, now I want 75% to go to the older version and 25% go to the newer version. This is our reality right now. The minimum that you can redirect is 25, which is already too much. By the amount of users that you have. I got a call here in my cell phone. Can you still hear me? Great, cool. So this is the issue for us because the amount of users that we get monthly and daily, 25% of their users is already too much. It would be already a severity 2 issue on those 25% of the users. So we are working to diminish that. I'm going to talk to that in a little bit. But going back to the Canary, now I can say, okay, remove everybody from the old version and go back to the and go to the newer version. Cool. But Rafael, what is the difference between Canary and Blue-Green? Right, blue-green deployment is blue-green is either everything or nothing. There is no percentage. So in a nutshell, it's either everything to the old version or everything to the newer version. You don't have percentage. But as I said, 25% is already too high. It's already a lot of impact to the users. So another flaw in my translation. So this is what we are trying to achieve twice is I have 100% of people using version A. I manual trigger version B, and then when I do a manual trigger of version B, 99% of the users goes to version A, and 1% goes to version B. And my automated release management would check our monitoring service. Of course, the developer needs to tell the monitor service what it needs to monitor for. And if anything goes wrong, if there are any problems in this monitoring, you would stop the release and you would shift all the users to the old version, version A. If there are no issues, the automatic release would keep releasing. So you would bump up from 1% to 10%, and you would keep in this loop until everybody would be in the version B. Cool. We also do feature toggle, which is basically it's an if else. You can say if it's an Eastern promotion is on, the price is 5 GBP. If not, if a promotion is on, then the price is 15 GBP. And it doesn't need to be true or false, on and off. You can have different levels. You can have maybes. You can have whatever it makes sense. So you can have different level of states in your feature toggle to map different cases, business cases. And we also do A/B testing, which is basically if the city is London, then test the new UI. If not, test the old UI, keep the old UI. And Facebook does this a lot. Google does this a lot as well. So we do this a lot to make sure that we are targeting. So let's say I'm releasing a feature right now for a smaller group. One of the things that we do is the feature that when we release is first released to the employees, especially iOS and mobile. We first release to the employees keep testing, keep using that new app for a while. And if nothing is reported by the employees, we send forward to the users, right? And we do the same thing for the front end. I forgot the name of the framework that we use to do A/B testing in the front end, but yeah, something similar. Cool. I guess I talked a lot. Thank you. This is my YouTube, LinkedIn, Telegram, and these are the references of everything that I talked about. You have the Martin Fowler prerequisite for microservices. You have the state of DevOps, the Accelerate book, the continuous delivery, and the Sam Newman microservice book as well.
Excellent. Thank you very much, Rafael. I'll share out those details with the recording later as well. But no, really fantastic talk. Thank you again for being with us this evening. I haven't seen any messages come through into the chat box, so I don't know if anyone's got any questions for Rafael. Then feel free to open up the audio or drop it in the chat function now, and we can run through those quickly.
Well, maybe I'll ping you a question, perhaps, if I may. You touched on the end-to-end tests, and when I think you were talking about the contract testing, you were suggesting that maybe that might mean that we don't need end-to-end tests anymore. Do you still find that you're using end-to-end tests? And if so, are you catching many defects at that point, or have they already been caught?
So that's very interesting. So that the idea of not having any end-to-end tests and you have your functional and contract tests, that's the idea of Sam Newman microservice book. I haven't seen that fully working 100%, remove 100% of all your end-to-end tests. So I thought we could do that otherwise, but it turns out that we still need end-to-end tests. We have some sort of, we are using right now custom environment for automated tests. So you have a small set of smoke tests to make sure your integration is working. So I still, at least at Wise, we still see the need. I talked to a couple of friends related to this. They also still see the needs of some end-to-end tests. There is like a book, Testing at Google, that also they wanted to remove all of their end-to-ends, and at the very end of the exercise, they still had to do some sort of end-to-end tests. So that's, I wish we could remove all of our end-to-end tests at some point, but like really hard to isolate everybody, right? Because you need to be able to isolate in the bounded context of the service. So some of our service, we are able to isolate pretty well. So if you are using like the activities in TransferWise, where it checks how you are using your money, they are able to isolate themselves pretty well. But as I mentioned, we have some teams that map a market. So they are adding functionality to the whole market. So that team is a horizontal team. It does not have a single bounded context. It touched the whole flow of the whole company from the very beginning, from onboarding a new user all the way to that user sending money. So that team cannot isolate themselves at all because their functionality touch 60 services. So they are not able to isolate. So in that way, we still need to do end-to-end tests. I'm not sure if you have an experience that I would love to hear that from you.
So yes, where I am at the moment, we're looking at trying to get onto continuous delivery, and one of the obstacles there is end-to-end tests, because it doesn't really fit with being able to automatically deploy through different environments and get into prod quickly. So we're looking at everything we can to remove the need for those and get all the tests automated and on the pipeline. Yeah, we're doing fairly well with Pact in some places. Again, it's just not all our services are there, but we're moving towards the approach that Pact is aligned, as you mentioned earlier, for consumer-driven contract tests. So we're trying to align in some ways with the idea that if you're a consumer service, it's in your interest that you get a response and request that you send that's understood, rather than the API having to manage that. So we're kind of pushing that expectation onto the consumer teams, who will also write the tests. So yeah, watch this space. Time will tell.
Cool. How many servers do you have there?
We don't have terribly many. We're running a form of Kubernetes, so we're moving a lot of stuff that is legacy and big monolithic applications and splitting bits up at a time, while we are building the new functionality onto microservices and micro front ends. So we're probably, I don't know if we've got 100 services yet, but I imagine it's probably in 2 figures at the moment.
That's a lot. In my experience, some of the new services, like you wake up one day and out of the blue you have 10 more services in your architecture, like they keep popping up.
Yeah, and I guess that's what we're striving to get is the benefit of microservices, which is, one of the big parts there is the independent deployability. So if you've got to test them together, then you kind of lose some of that independent deployability, right? So yeah, it's all about how to get rid of those end-to-end tests.
Correct. Yeah, I agree.
Excellent. Thank you very much, Andy. Anyone else have any questions at all for Rafael? Yeah, just obviously open up your audio and fire away. I'll take that as no more questions. So thank you very much again, Rafael. Fantastic talk. Thank you everybody for logging in. I'll share out the slide deck if Rafael's happy with that, and also the recording probably tomorrow or Friday. And I'll drop you in some details of our next talk at the end of July. But yeah, thank you everyone. If you've got any questions that pop up, feel free to message me directly or Rafael, and we'll get those answered. But yeah, have a great evening and see you on the next one.
Thank you, everyone. Bye.